Can one data center campus hide its carbon output by leaving the power grid? Amazon's planned West Texas site is permitted to emit 33 million tons a year, more than any operating U.S. coal plant. But here's the thing. Spread across the grid, carbon has no author. It dissolves into everyone's power mix and nobody has to answer for it. This permit holds a single massive number with a single company's name on it. So here's the claim I'll stand behind. The build-out's carbon can hide in accounting, but public measurement is dragging it into daylight. That's today's lead. Also in today's episode, ByteDance tests the frontier fence, companies audit their AI bills, and brain cancer researchers pair treatment with an escape map. Come with me, let's get into it. People in rural Pecos County, Texas could soon host a fossil power plant built to serve one company's data center campus. The plant's carbon permit is the clock hanging over them. So how large is the burden? Well, it's large enough to break the usual comparison. Texas has permitted the plant to release up to 33 million tons of carbon dioxide each year. If fully emitted, that would exceed the annual emissions of any coal plant now operating in the United States. A New York Times investigation surfaced the project just yesterday, on Saturday. Amazon plans to back the campus with a private generating station of roughly 35 gas turbines. Together, they would provide nearly 8 gigawatts of power. So that is fossil generation built from scratch at coal plant scale for a single buyer. Resource objections around data centers often arrive without proportion. A large number gets pulled from a permit and presented without the farms, the factories, the homes, or the other industries using the same resource. But that approach doesn't survive contact with this permit. The plant's allowed emissions exceed every operating U.S. coal station. The comparison is already built in. And then there's the route that Amazon chose. The generating station would sit outside the Texas electric grid. That means it also sits outside the cost rules that regulators have been tightening around grid-connected data centers. Virginia has moved to bill developers directly for the substations that they trigger. Texas is auditing giant new loads before they connect. Those steps make the companies carry more of the infrastructure cost that their campuses create. But an off-grid plant slips around that system. It may spare the public grid from the load while shifting the cost into the atmosphere and the community hosting the turbines. An Amazon spokeswoman said that the project won't raise electricity costs for Texas families. Because the plant won't connect to the public grid, that statement addresses one specific bill, the money one, but it leaves the emissions untouched. Speaking about Amazon's climate pledge, the spokeswoman said, "The world looks different now than when we co-founded it." But she also said, "Our commitment hasn't changed." Amazon's reported emissions rose 16% just last year. A plant permitted at this scale would push that line much further. And this is not an isolated Texas filing. Days before the investigation appeared, Amazon filed for 2 more campuses in the state and an expansion at a third. Pecos County is rural and thinly populated. It doesn't have the legal firepower that wealthier communities can marshal against a giant industrial project. When affluent places defeat a burden, companies often move it somewhere with fewer lawyers and fewer people who can spend years fighting the permits. The transition needs new power. It also needs honest accounting and fair siting. Building compute does not require treating any community as a sacrifice zone. But this permit does give the public something it rarely gets from a sprawling data center build-out: one number, one plant, and one company attached to the cost. That visibility creates the chance to compare this plan with cleaner generation and make the next developer answer before the turbines arrive. All right, from Amazon routing around the grid to ByteDance moving beyond an export boundary, the labs charging a premium for frontier reach now face a rival training at their scale. Does 10 trillion parameters guarantee a frontier model? Well, no. More parameters roughly add capacity while performance still has to be proven, but the break here is in who can afford to make the attempt. The Financial Times reports that ByteDance has begun early training on a model with up to 10 trillion parameters. Parameters are the adjustable weights that hold what a model learns, and that would make the model roughly 3 times the size of Moonshot's Kimi K3. It also approaches some outside estimates for what Mythos, which is Anthropic's most advanced system, might have. ByteDance is TikTok's parent company, and its seed research group develops frontier and open models. Its current flagship is about 1/3 this planned scale. training a model this large costs an enormous amount of compute that used to be part of the frontier lab's protection. Very few organizations could assemble the chips, the power, the money, and the research talent needed to even try. But ByteDance is trying anyway, in the open and past the scale that export controls were designed to fence off. Access restrictions can slow the movement of hardware, but they cannot preserve a permanent monopoly on knowledge, engineering skill, or scale. Once several groups can reach the same range, the premium attached to being the only lab there begins to really thin. Now, we still need the finished model and independent results. 10 trillion parameters describe the size of the vessel, but not how well it sails, per se. But the frontier now has another builder standing at the edge. More competition at that level can push capability outward and lower prices and weaken the idea that advanced intelligence belongs only behind one company's gate. All right, from the frontier scale to the buyer's invoice, companies are finding that AI spending can swallow a budget before anyone knows what the work actually bought. So, was the problem the price of AI or the lack of a meter? Rippling's answer was to install the meter, and once it did, model prestige started losing to price. Rippling makes software for payroll, human resources, and company IT. It discovered that it was on track to spend the equivalent of 40% of its entire research and development headcount budget on running AI models. The company responded with an AI spend console. It tracks token use by employee and tries to map which spending creates value and which produces simply slop. So as you probably know, tokens are the chunks of text that AI providers use for billing. A few requests cost very little, but across an entire company, those tiny charges really grow and can become a major operating expense. Once Rippling could see the bill, then it could try to test substitutions. And the company says that it found an open-weight model that produced nearly identical output on a particular workload for 85% less than the premium leader. Now, open-weight, as you probably also know, means that the model can be downloaded and run directly. And typically they are also available via API through various vendors and at a much reduced cost compared to the frontier. So these options give companies other solutions besides paying a frontier lab each time someone sends text through the model. This is where measurement changes the market. If two models clear the same quality bar, then the cheaper one takes the work. A premium brand can't defend a huge price gap forever when buyers can place the outputs side by side and show no difference. The other side of the ledger is what the spending buys. Airbnb reported that AI cut its time from a new concept to launch by 60% as the company tests a new search function. That kind of gain can easily justify serious spending. The meter lets a company separate that productive use from a flood of expensive output that nobody needs. And then there's also a limit on how far prices can even fall. DeepSeek, whose cheap open models helped to trigger the global AI price war in the first place, has announced a significant API price increase among surging demand here. The price hike shows the race downward does have a floor. Now, the open path still works, compute still costs money, and heavy demand raises the value of serving it. The deeper pressure remains. Companies now know that they can move work between models. They can compare quality, meter each token, and send the job to the cheapest system that does it well. That makes AI less like an open tab at one premium provider and more like an ordinary input that buyers can shop, own, and manage. As the meters spread, more of the savings can stay with the people and the businesses actually using the capability. All right, from measuring what AI work bought to measuring what a cancer treatment could endure, 15 people with recurrent glioblastoma faced a tumor that had already returned. Researchers gave them CAR-T, immune cells rebuilt to recognize cancer straight into the brain. Could the treatment be repeated without side effects, forcing a stop? After 72 infusions, none hit that stopping point. Now, glioblastoma has been one of oncology's hardest walls. The tumor grows into the brain, returns after treatment, and stays protected by a barrier that keeps many medicines in the bloodstream from reaching it. CAR-T has transformed treatment for some blood cancers, but solid tumors have been much harder, especially inside the brain. In this phase 1 trial, researchers engineered the immune cells to recognize a marker found densely on glioblastoma cells. They then infused those cells directly where they were needed. 13 of the 15 patients tolerated repeat dosing as well. Researchers never found a dose-limiting toxicity, the side effect ceiling that usually forces a trial to stop raising the dose. They reached the planned ceiling without ever finding the maximum tolerated dose. Now, patients still had some side effects. Most of them experienced cytokine release syndrome, which is an inflammatory surge caused by immune activation. Other effects included temporary rapid heartbeat, vomiting, high blood pressure, and even raised pressure inside the skull. And researchers did record 3 serious grade 3 events, which they will have to, of course, work on, but that is the point of these trials. The early benefit signals were encouraging. Roughly 2/3 of the patients were alive after 1 year. Median survival actually reached just over 19 months, which is well above historical benchmarks after glioblastoma returns in this 15-patient phase 1 trial. Now, samples of the fluid around the brain and spinal cord also showed the transferred cells multiplying after infusion. In other words, the therapy reached the target and even expanded where the researchers had placed it. And then a companion study supplied the map to this. The researchers used a method called InSight to read which proteins were switched on inside fixed tumor samples. In patient-derived models, it caught escaping tumor cells changing their behavior right at the tumor's edge before they had traveled very far. That second map identified possible targets for blocking the spread. It gives future treatments more than just the tumor's location. It also shows what the escaping cells are doing as they move. Now, the clinic still sits beyond larger trials and regulatory review. 15 patients can establish a very early safety path and surface a benefit signal, but they can't settle whether the treatment even works across the wider patient population. But still, 2 parts of the problem did tighten at once. Researchers repeatedly placed engineered immune cells inside the brain without reaching the trial's toxicity limit, and at the same time, they mapped the first steps that the cancer takes when it tries to get away from the treatment. The distance between reading this tumor and hitting its escape route has become shorter based on this. Now, larger trials can test whether that closing distance gives more patients more time. All right, let's close it out. Today kept turning hidden things into things that we can count. Amazon's off-grid plant looked separate from the public's power system. The permit still put a number on its carbon, and that number exceeded every operating U.S. coal plant. That changes the argument. Compute also has an energy cost. Can companies scatter these costs across grids and contracts and communities until nobody can see who carries it? In Pecos County, that answer is becoming visible. The same shift appeared in the AI market as well. ByteDance's 10 trillion parameter training run makes frontier scale harder to present as the private territory of a few labs. Rippling's console makes token spending harder to leave as an open tab. Once the company measured output against price, an open model came in 85% cheaper. And in the glioblastoma studies, researchers made 2 hidden processes visible at once. They tracked engineered immune cells expanding inside the brain, and they caught tumor cells changing their signals at the edge where escape begins. Measurement doesn't solve any of those problems by itself, but it changes who can check the story. A carbon permit can expose an externalized costs. A spending console can break a premium provider's hold on a workload. A signaling map can show a treatment where the cancer plans to move next. So that is the hopeful thread running through today. What can be counted can be compared. What can be compared becomes harder to hoard, overprice, or push onto someone without an answer. The carbon from this build-out won't stay hidden forever. Neither will the falling costs of intelligence, the widening frontier, or the paths through a tumor that once looked impossible to follow. The future gets easier to build when more of us can see what it costs, where it delivers, and where the next opening lies. See you tomorrow.